Hello, this is lesson 4.1.3, How Does It Grow? Connecting Linear Rules and Graphs. You have been looking at geometric patterns and ways in which those patterns can be represented with XY tables, graphs, and equations. In lesson 4.1.2, you worked with 4 different tile patterns and looked for connections between the geometric shapes and the numbers in the equations. Today, you will go back to those 4 equations and look for connections to other representations. By the end of this lesson, you should be able to answer the following target questions. How is growth shown in a graph? How is growth shown in a rule? How can you determine the number of tiles in figure 0 from a graph? How can you determine which tile pattern grows faster from a graph? Now, what I'm going to suggest to everybody today is when you turn over to the next page, it says, in your teams, complete the missing tile patterns. I would like you to really challenge yourself to try this on your own. So you're going to draw figure 4 and 0 for each tile pattern. Now, it's a really good challenge. It took me a minute to complete as well. It will be a good usage of class time and is going to totally prepare you for what's to come for when it comes to our formatives and summatives. So pause the video. Why don't you give it a try here? I'm going to put our answer up for what the tile patterns would look like. And those are what our tile patterns should look like here. Now, if you're looking for a little justification, I found that in our first tile pattern, number 1, that there was 4 right there. It went to 6, so it goes 4 in the middle, 6, 8, so there would be 10 in the middle. Now on each end, there's 1 and 1, 2 and 2, 3, 3, so there would be 4 and 4. In tile pattern 2, I saw that there was 1 getting added on each end, so that center point stays the same throughout, but there's 1 and 1, 1 and 1, then it goes 2, 2, 2, 2. There's 3 on each end, so we know it's going to go in 4. And as always, whether it's tile pattern 1 or tile pattern 2, we just go backwards with those. There'd end up being 0 in tile pattern 2, nothing on the wings, and then that center point would even go backwards in 1. In tile pattern 3, this one was a little tricky. What helped me when I was doing it was I saw that there's these little stacks on the end that we're adding, and it looks like this little 3 in each of the patterns stayed consistent. So I drew that as a line just to keep it consistent. So I saw there is a stack of 3, well, like 3 in the height, and it's going to stay 3. So it'd be one little stack, and that 3 stays again, 2 little stacks, that 3 stays, 3 stacks, so then we know that 3 is going to stay, so there'd be 4 stacks. On the front, it goes 1, 2, 3, and 4. So we know that going backwards, there'd be 0 on the front, there's that little line that goes across, and our stacks on the other end would disappear completely as well. Tile pattern 4 was a weird one to look at as well. We know that we started with this little kind of cross looking thing. Now I still see the cross right here in our image. The cross is right here as well in all of our images. And if you look, it's adding 1 on each. So then there'd be 2 and 2. It's dropping 3 and 3. So we're going backwards with that. There'd be nothing left, not even the original cross with the 2 on the end. But we know that front's going to stay, or that middle column. That's how I justified making those patterns. If you need to rewind the video and go back before all these little marks got drawn on here, you can totally do that as well. Now, going on to our next pattern, there were some tables here that we're supposed to fill out. I'm sure you would have all figured that out by now as well. If you need to make a pause and challenge yourself to fill out these patterns, otherwise we're going to do that here. So in tile pattern 1, in figure 0, there's 2. In figure 1, there's 6. In figure 2, there is 10. So we know that there is 14 and 18. In tile pattern 2, we got 1. In figure 1, we got 5. Figure 2, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. I see that we have a pattern developing, so we can go 13 and then 17. In tile pattern 3 here, count 3 tiles. And figure 1, there would be 3, 6, 7. In figure 2, there would be 3, 6, 9, 11. Once again, it's adding by 4. And last but not least, in tile pattern 4, we have 3 in figure 0. In figure 1, there would be 3, 4, 5. In figure 2, there would be 2, 4, 6, 7. This one's changing it up and straying from that slope of 4. So it's changed by a slope of 2. I'm going to go back on my tables now here, guys. I'm going to draw in my little slope marks and circle the y-intercepts in each of them. Maybe you already beat me and worked ahead of it. I always show off the important information, and once you get the hang of it, folks, it really becomes second nature. I don't even think anything of it now. But there is a really big, valuable lesson in showing this work and always going the extra mile, because there is times where you will make mistakes in life and in general, and if you have the work there, you can go back and you can figure out what went wrong. And if you don't have it on there, it's going to take a lot longer, and you might even have to restart from square one. So that's why I show the slope and y-intercept. So I'm even going to write my slope was 4, y-intercept was 2, my slope was 4, my y-intercept was 1. So although the slopes might be the same, it's kind of interesting. The y-intercepts are certainly not the same. Slope was 2, y-intercept was 3. Interesting stuff. So we're going to actually use this collection of data. Oh, not that page. And we are going to graph all of these tables on the same set of axes. Now, this graph needs a lot of TLC. So I'm going to put our x, our y, our 0. We know that the x is going to be the figure number, and our y is going to be the number of tiles. Now we also need to count our axes here. Now, if you're looking at all the tables, they all go from 0 to 4 in the x. So that's going to be pretty easy to put on here. I'm going to actually create some more space so they're not all so close together. I'm going to go 1, 2, 3, 4. Every 5 tiles over, I'm going to put a little tick mark. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. So what those little tick marks represent is, if that's figure 0, that's 1, 2, 3, 4, and 5. Now it's going to be a little different for our y, because the numbers in all the tables because we got to put 4 tile patterns on here. One goes to 18, one goes to 17, 19, and 11. So thinking of a range of numbers that would probably fit that we could put on our y-axis here is 0 through 20. Our highest number is 19, our lowest number is 1. 0 is already right there. Right here I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, we got easily enough space to fit all 20 on there if we wanted to. So I'm going to go 1, 2, 3, 4. Every 5 tiles I'm going to put a mark. I'm going to count that by 5, meaning that each individual line right here is counting by 1. So that'd be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. You can even go beyond that if you really wanted to. 21, 22, 23, 24, 25 would be at the tippy top. Now we got to make our graph in tile pattern 1. Our first point is 0, 2. So that's 0, 2. Next should be at 1, 6. So we go over 1 and up to 6. 2, 10 would be our next. So I go over to 2 and up to 10. 3 would be at 14. Over to 3 and up to 14. And 4 would be at 18. That's 20, 19, 18. 418. Now I'm going to connect these dots here with a line. Now guys, I extend that line super long here. If you need to get access to different writing utensils, like color-wise, I'm going to recommend that you put all 4 of these graphs in different colors. So if you have your own pens, you can use those. In my little cabinet at the front of the classroom, you do have permission to go and grab any of the markers that you might need. You can go use markers for it as well. I also got colored pencils in there as well. So this is tile pattern 1, so I'm just going to write number 1. Tile pattern 2 starts off at 0, 1. So that's going to be 0 and 1. Next, it's going to go to 1, 5. So 1, 5, 2, 9. Oh, interesting. You know what pattern I'm already picking up on here, guys? It's 1 below the red dot. And when you pick up on that pattern, you can go ahead and you can put that as well. I mean, you can do that with any linear lines. Linear lines are born to make predictions. Went a little beyond my ruler there. But those lines never touch each other. So that's a little observation that we made, or can make. Tile pattern 3. So that means, you know, if they have the same line and they're both straight but they never touch each other, that means they must have the same slope, but they're starting at different spots. Figure 3 here, we're going to graph figure 3 is at 0, 3. So 0, 3. Another line didn't start at the same spot, but look, we already knew the slope in all of these was 4, 4, and 4. So it's going to have the same slope. I'm just curious here. So 0, 3, we plotted 1, 7. It's 5, 6, 7. It's 1 up on our other points, or that red line. Number 3. So all these lines never touch each other. They all have the same slope. Let's see how this last graph, if it throws off anything. It's going to be blue. Might be kind of hard to see here. compared to that black. So in tile pattern 4, it starts from 0, 3, 0, 3. So it starts at the same spot as that black line. Next point would be at 1, 5. So 1 and 5. Ooh, goes into that green actually that time. Next would be 2, 7. 6, 7. Then it would be 3, 9. So that's 10, 9, and then 4, 11. So 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As always, I'm going to connect the dots here. Remember, it started on that black dot, so it's kind of hard to see. Easier to see once you draw that line there. So that would be our number 4. That is what graph we should see, so that clearly that line 4 intersects and touches lines 1, 2, and 3. Starts at the same spot as number 3, but lines 1, 2, and 3 never touch each other. They have the same value for slope and different y-intercepts. So it says in D, explain how the growth appears in the pattern in the table and the graph and the rule. Well, we didn't make our rules yet in any of these. So we can go ahead and let's make a rule in each of our tables. So we're going to turn back to our little tables here. We already got our slope and y-intercept basically made. So that would be y equals 4x plus 2. Y equals 4x plus 1, y equals 4x plus 3, and y equals 2x plus 3. So if we're looking at all our representations, we can say the slope is the same in number 1, number 2, and number 3. However, the y-intercepts are all different in 1, 2, and 3. Now guys, this little sentence right here, it actually can summarize all the pattern, table, and graph and rule, because we knew from last lesson that the table, graph, rule, and pattern are all related to each other in these linear contexts. So we got one little explanation here. I think that we should make a comment on number 4 here. We can say line number 4 has a different slope than the others, but has the same y-intercept as number 3. I'd make a pause if you need to, and you can get caught up. And for part E here is, guys, in E, I mean, this is just more observations and connections to what we see here. Maybe I'll just extend this a little bit further, so we can say extend lines number 1, 2, and 3. Because these lines have the same slope and never touch each other, that's called parallel. So we can say lines number 1, 2, and 3 are all parallel to each other. Then we can say line number 4, now when a line goes through another line, that means it intersects. So we can say line number 4 intersects all of the other lines. In geometry, that's something called the transversal, but you guys are not quite there yet. If you need to go back at any point in the video, please do. I know today was a long video. Tomorrow will be a short video, so if you need to get caught up, then you can totally do that as well. That concludes our lesson today. Thank you.